Alright, welcome to CHEMCASTS. You know, I got to thinking that 40 years ago we put a man on the moon. It's about time that we put a little chemistry onto YouTube. So the idea of CHEMCASTS was born, and here we are, episode 1. And what we're going to do in this first episode is just continue the discussion that we've had on naming coordination compounds in class. And so there's a few examples posted on the web of practice problems, and also posted on the web is this rules sheet, this rule list that you took notes on for the rules for naming coordination compounds. If you haven't looked at that since class, now would be a good time to do that. Pause the video, look it over, come back to the video. I think everything will make a little bit more sense. So let's just do one of these examples. Let's do the cobalt example. So we have cobalt, alright, and so coordination compounds, your rules say that we need to name the cation first. So we can think of coordination compounds, they're just like a salt, where salts we name the cation first. Sodium chloride, we say sodium, the cation first. So the first step in naming these coordination compounds is to figure out what's the cation, what's the anion. So we're used to seeing hydroxides as anions, and so it is. So we have an anion, which means our complex ion is our cation. And now we have rules for naming, so we're going to name our complex ion first because it's a cation, and we have rules for naming this complex ion. And the rules say that we list the ligands before the metals, and the ligands we order alphabetically. And if there's more than one type of ligand, or more than one of the same type of ligand, that is, we use these prefixes we need to indicate how many of the ligand there is. So we have this amine ligand, and we have this hydroxo ligand. So it's hydroxide usually we think of, but when it's a ligand we call OH hydroxo. Just one of these rules. So we have 5 of these amines, so we say pentaamine, but we use just the name of the ligand, not the prefix, as the alphabet in order to alphabetize them. So we start with our amines. So pentaamine, now we have hydroxo. Now we need to add our metal ion in there. So we have cobalt, and we need to indicate the charge of the cobalt. So this is an overall neutral molecule. The coordination compound as a whole is neutral. There's no charge written. So we have hydroxides are usually -1, so we have 2 of them. These OH groups contribute -2 charge. This OH contributes a -1. Amines are neutral, so that means our cobalt has to be +3. So we have pentaamine, hydroxo, cobalt 3. So we indicate the charge with this Roman numeral in parentheses. And now we need to name our anion. And so we just name it as usual, hydroxide. So pentaamine, hydroxo, cobalt 3, hydroxide. And one thing to point out, this complex ion, the convention is to just run all these letters together, no spaces between the words. So it's just a big mess of letters, but we do have a space between the complex ion and the counter ion. So there's a space right there. So pentaamine, hydroxo, cobalt 3, hydroxide. Hopefully not too bad. And so let's do the reverse, where we start with a name and go to a formula. So let's erase what we have on the board. And we'll do another example that was posted on the web. So let's do the potassium bromo trichloro platinate. So potassium bromo trichloro platinate 2. And so when going from a name to a formula, the best way to think of it is just we use our rules in reverse. So let's start with the metal in this case. So platinate tells us that our complex ion is going to be negatively charged because we added this 8 to it. So the 8, you can think of other ions like sulfate, nitrates. They all have these 8s at the end. So our complex ion is going to be negative. So let's start with platinum. So we have platinum, we have a bromo and a trichloro. So bromo, trichloro, that takes care of our complex ion. Now we need to add our potassium, but we need to know how many potassiums to add. And to do that, we have to look at the charge of the atoms. So chlorine contributes a -1, but we have 3 of them, so that gives us a -3 from the chlorines. Bromine contributes a -1. Platinum, we were told, was 2+, so platinum 2. So for our coordination compound to have an overall charge of 0, that's what we're going for, neutral, we have a -2 charge for our complex ion. That means we need 2 potassiums. So 2 potassiums. And this is the formula that corresponds to this name. So concludes episode 1 of CHEMCASTS. I'll let you see the board if you still need to look at it. Who knows how regular these airings will be? Check back and we'll have fun again.